Alright, 12.5, surface area of pyramids. Objective, students will be able to find lateral and surface areas of regular pyramids. So, what is a regular pyramid? Let's define it. A regular, man, handwriting is really bad. Pyramid has a regular polygon as a base, and the segment that connects the vertex being the top corner of the pyramid, and the center of the base is perpendicular. I'm just going to do the perpendicular symbol there to the base. And the center of the base is perpendicular to the base. And then the slant height this is the height of each lateral face. So if you were to have a pyramid, which we do on the very next shot here, it would be the height of the side of the pyramid. So let me show you that. So you see here we have a pyramid. This is just a regular, or this is a square pyramid, and notice it's a little bit oblique, it's kind of off-centered. And this is a regular square pyramid, so all the lateral sides are the same. The altitude is also right where the axis is. It goes right from the vertex to the center of the base. And here's the slant height, guys. It's this height of the side of one of the sides. So there's a slant height here, the back side, on this back side. So there's slant heights on every side. Alright, so how do we find the lateral area of a pyramid? Well, there's a formula for that. So let me zoom in. It is L equals 1/2 perimeter times L. And the L represents the slant height. So here's a problem. It says the roof of a birdhouse is a regular hexagonal pyramid. The base of the pyramid has sides 4 inches, and the slant height is 12 inches. If the roof is made of copper, find the amount of copper used for the roof. So that's a lateral area problem. We got a slant height of 12, but we need to find the perimeter. Remember, it's got a base of a hexagon, so that means that there's 6 sides, and they're all 4 inches wide. So the perimeter has to be 4 times 6. Alright, if you guys want to figure out the rest of this problem on your own, go for it. You may want to pause the video. Otherwise, I'm just going to do it here for you. Alright, so we know that the lateral area equals 1/2 the perimeter times the slant height. So we would say 1/2 of the perimeter. Well, 4 times 6 is 24. So we're going to say 1/2 24. And if we look at the picture, they tell us that the slant height right here is 12. So that's what I'm going to put in for my slant height, is 12. And as I go to multiply this through, half of 24 is 12. And then I can just bring down this 12. Sorry, that was supposed to be an arrow. Bring down this 12, and you get 12 times 12, which is 144 inches squared. And there we go. That's it. That's the lateral area of that copper roof. Okay. What if we wanted to get the whole surface area of a regular pyramid? Well, surface area is not that much different. I mean, lateral area is all these sides, so the only thing we have to add to it is this base. And so, yeah, the surface area is 1/2. I should have given myself a little bit more space. Slant height plus the area of the base. So whatever the base is, you just have to add that area to it. So if you take a look at this problem here, find the surface area of the square pyramid with a height of 24. Okay, so we actually have a height of 24, not a slant height, but just a height of 24. And each side is 18. Well, we could get the perimeter, we could get the base area, but we don't have the slant height. So how are we going to get that? Well, here's what I say. Let's zoom in on this guy. And this is what the 24 is. It's that altitude going straight up and down. And then there's this part of that. and you notice it makes a little triangle. Let's redraw this right triangle out here so we could kind of get a better idea for it. They said this is 24 meters. Alright, so 24 meters, 18 meters. And then you have this little side thing. Well, obviously this is right in the center. If it's a regular pyramid, that means this has to be exactly half of one of the sides. So this little red distance here has to be 9. Well, if it's 9, then we should be able to use Pythagorean theorem to figure out what the slant height is. This guy. So we're going to say 9 squared plus 24 squared equals L squared. 9 squared is 81. 24 squared is 576, and we don't know what L squared is. But we do know that it's equal to 576 plus 81. So let's see what that is. 576 plus 81 is 657. And now the last step here is to take a square root. Take a square root. And so we get that L equals the square root of 657. Well, I'm going to do that up here in the corner. The slant height equals the square root of 657. Okay, so that's a really big square root. And so one of the things that we want to do is we want to simplify these if we can. So what I like to do is I like to just check and see if there's any perfect squares that go into it. Right away, I see that 6 plus 5 plus 7 equals 18, which means that this number is divisible by 9, because 18 is divisible by 9. And I know 9 is a perfect square, so let's break that down. So if I was to divide this thing by 9, I think I'd get 9 and 73. 73 doesn't break down, but 9 does. It breaks down to 3 and 3. So there's my pair. So I have 3 rad 73 as my slant height. And that would be the simplified way of writing that. Okay. Now I have my slant height. I should be able to figure out my perimeter because I have one side. I'm just going to multiply that by 4. My base area is just going to be 18 times 18. So yeah, I'm ready to go. Let's plug all these things in. 1/2 perimeter is 18 times 4. Slant height we said is 3 rad 73 plus the base area is just going to be 18 squared. Okay. Let's do this. At this point, you could plug all this in your calculator if you really wanted to, unless they ask for an exact area. So I'm going to work out an exact area with you guys so we can get there. So we got 1/2. 18 times 4 is 72. Times 3 rad 73 plus, and 18 squared is 324. Half of 72 would be 36. So now we have 36 times 3 rad 73. And 36 times 3 is 108 rad 73 plus 324. And that would be the exact answer. But now we can actually plug that in a calculator, see what we would get. And when I plug that in, I get T equals 1, 2, 4, 6. And let's round to 2 decimals this time. We would get about 75. And we were dealing with meters, so this is meters squared. So there's my answer. Okay. Example number 3 is the last one on here, and it is definitely a tricky problem. So I think what I'm going to do is I'm going to just do example number 3 in a separate video. It's got a lot of steps to it. So, yeah. I'll see you guys on the 12.5b video. This will be 12.5a.